Welcome guys in the continued tutorial of these signals in the DSP. So in the previous video we have discussed some commonly used signals in the digital signal processing, and in this continuous session of this video we will discuss the sinusoidal signals used in the digital signal processing. So guys, before starting this video I want to tell you, please subscribe my channel, like the videos, and if you have any query please write in the comment section. So let's start the video. So what are the sinusoidal signals? So guys, sinusoidal signals that have include the sine wave and cosine wave signal, means the signal that is representing the positive and negative cycles. So this is the sinusoidal signal basically. So sinusoidal signals are the two types of signals that are first one is the sine wave signal, second one is the cosine wave signal. As you can see in this figure below, this one is the sine signal, sinusoidal sine wave signal, and this one is the cosine wave signal. So mathematically we can represent as these two sine and cosine wave signal as, for A is the amplitude of signal. Here first we will study from this image, this figure. So here this is the origin point O of sine wave, and this sine wave is start from this origin point. Sine wave start from this origin point and then continuously increase up to the t number of cycles. So this the amplitude of this sine wave that has A, and the signal that is x of t signal of this sine wave signal. And similarly for the cosine wave, the difference between them, sine and cosine wave, the cosine wave is not starting from the origin, it is start from the amplitude of that particular origin, and means it has, when the cosine wave start it have some amplitude, and when the sine wave start it has no amplitude, it is zero. So this is the difference between them. So cosine wave is starting from this x of t, from the amplitude of that origin, so and increase the continuously with the t number of cycles with respect to time t, and the signal that is x of t, and it has the amplitude also A. So these are the sine and cosine wave signal. So the derivations, the mathematically representation of this sine and cosine wave signal. First one is the A, this is a sine wave signal. A is the amplitude of sine signal, so that is representing by x of t. X of t is the signal of sine wave, that is equal to A is the amplitude of sine with angular frequency omega, and t omega t with respect to time. So here the value of the omega is 2 pi f. So here A, substitute the value, and A of sine, amplitude of sine with respect to time, that is angular frequency omega is equal to 2 pi f. And similarly for the cosine wave, cos signal, so A is the amplitude, that is x of t, same signal, that is A cos omega t, and omega is changing to 2 pi f. The value of omega is 2 pi f, that is angular frequency. So A cos 2 pi f t. So this is the mathematical representation of these sinusoidal signals. So first signal is continuous sinusoidal signal. So in the continuous sinusoidal signal, this signal is representing as the continuous wave, this wave, and here x of t, this is the continuous signal, and these above equations are the continuous signal. So in the continuous, the signal is representing as x of t. T represent the continuous nature of the signal. For both sine and cosine signal. So x of t represents the continuous signal. So let's move to the discrete sinusoidal signal. This one is the discrete sinusoidal signal, discrete time sinusoidal signal. So here you can see in these waveforms, this first waveform, that is for discrete time sine wave, and second one is a discrete time cosine wave. So in the first sine wave, here the same signal, same the back, the wave that we have seen in the back page, previous page, this wave, but in the discrete form, this on the place of these waves that have on samples some digital internal values. These values, these are the samples. So in the this is the negative cycle and this is the positive cycle of this sine wave. So in the negative cycle and positive cycle have different negative and positive values in this sine wave signal. So here this is the origin, and from the origin this is minus infinity to this plus infinity, and from 0 to minus infinity that have the negative values, minus 1, minus 2, here minus 1, minus 2, minus 3, minus 4, minus 5, these values are the negative values, and from 0 to plus infinity that have the positive values 1, 2, 3, 4, 5 up to n number of the n times samples. So with the increasing of these cycles, these number of the values will increases, and these are the digital discrete form of this sine wave, and this signal is represented with x of n. X of n, digital signal is represented with x of n. So for the sine wave, here this is this discrete sine wave denoted by x of n. So the signal x of n, that is a is the amplitude with sine of omega n. So omega is equal to 2 pi f, that is the angular frequency, a is the amplitude of signal. Here this is the amplitude and this is the positive amplitude, and this one is the negative amplitude of signal sine wave. Similarly for this cosine wave, that have also the positive and negative amplitude, and the values, the discrete samples are in the form of positively as negatively from minus infinity to infinity, plus infinity and minus infinity, from 0 to plus infinity and minus infinity, that have the values, discrete values of different samples. So the x of, similarly for cosine wave, x of n, mathematical representation of discrete form, that is the x of n, cosine wave x of n, that is the a cos omega n. So this will be when we substitute the value of the omega, that is 2 pi f, then this signal x of n, that will be a is the amplitude of signal with 2 pi f and n. So this is the angular frequency and n number of cycles, discrete samples. So this is the discrete form of this sinusoidal signal. So for this video, that's all for this video, guys. If you have any query regarding this, please write in the comment section, and in the next video we will discuss the remaining signals of this digital signal processing.